So I left because I wanted to grab a coin just to demonstrate, because sometimes the number of heads in 2 coin flips is a little confusing if you're just thinking about it with words. So here's an example of our event. We've got this nice coin here. That time we got tails. That was our first flip. And on our second flip we got heads. So the number of heads that we got in that event was 1. Of those 2 coin flips, 1 of them came up heads. So we could do another event, right? So that was a terrible flip, but our first one came up tails, and our second one came up heads. So for that one, our outcome was, again, 1 heads in our coin flip. And so what we're going to do here is we're going to come up with a probability distribution. And we know what the format of the probability distribution is going to be like. Probability. No. Okay, so probability. Sometimes I'm just dumb. All right, so probability distribution is what we're making. And in our probability distribution, we're going to have 2 things. One of them is going to be the values that we have in our variable. And again, we're going to say that our variable is based on the possible outcomes that we could get. So our variable is number of heads. And the numbers of heads that you can get from 2 coin flips is going to be 0, 1, or 2. You can't flip a coin 2 times and somehow get 3 heads out of those 2 coin flips, and you can't get, negative numbers of of heads or any other outcomes. You can either get 0 heads, 1 heads, or 2 heads. So the other thing that we need in our probability distribution is going to be our probability values. So what's the probability of getting 0 heads? What's the probability of getting 1 head? And what's the probability of getting 2 heads? And the thing is, when you have a coin like this, you can't actually go through and count up, all the outcomes and compare them to some number that you have in the population. Because you could flip a coin literally an infinite number of times, right? There's no denominator there. Instead, we're going to use our rules for calculating probabilities to fill in this column here. So I'm going to go through each one of these here, each of the particular outcomes that we could have. So the first one is 0 heads. And we want to know the probability of getting 0 heads when we flip a coin 2 times. And as we just went through, there's only one way that this can happen. You can get tails in your first flip, and then tails in your second flip. That's the only way to get 0 heads when you flip a coin 2 times. So what we're going to do here is we're going to think about our probabilities for getting heads and tails. And up here, I'm going to write, because this is just a regular quarter, our probability of getting heads is equal to 0.5. All right, so this is just a basic fact of a quarter here. You flip it, it has heads on one side, tails on another side. That means we have 1 chance of getting heads out of 2 chances of getting any outcome, which gives us a probability of 0.5. So we could also say that the probability of getting tails is 0.5, but for the sake of the exercise, I'm going to just talk about the probability of getting heads. So if we want to get tails twice, what needs to happen is that we need to get not heads on the first one and not heads on the second one. So if we're just using the probability of getting heads to calculate all these probabilities, we'd say that to get 0 heads, we have to get not heads on our first flip and not heads on our second flip. So in order to do that, and I'll write this out like this. So we'll say that to get tails and tails, we need the probability of getting not heads and not heads again. So this is an example of how our rules for calculating probabilities can be combined. So here we have 2 things going on. We want to know the probability of getting not heads in our first flip and the probability of getting not heads in our second flip. So here we're going to be looking at the probability of getting not heads and then the probability of getting not heads again. Our probability of getting not heads is going to be equal to 1 minus the probability of getting heads based on the converse rule. So our probability of getting not heads, and sorry, this is kind of going in multiple directions here, but the first component here, so the probability of getting not heads and then not heads, our probability of getting not heads is going to be equal to 1 minus our probability of getting heads. Our probability of getting heads, as we just said, is 0.5. So our probability of getting not heads is equal to 1 minus 0.5, which also is equal to 0.5. And as I said, you could just look at a coin and know that also, because you only have one chance to get tails or not heads, out of two possible outcomes. But now we're going to come back to this idea of getting no heads out of 2 coin tosses. And for this one, we want to use the multiplication rule. As we talked about before, the multiplication rule tells you the probability of getting one outcome and then getting another outcome. So we want to know the probability of getting not heads and then getting not heads again. So the probability of getting not heads and not heads is going to be given to us by the probability of getting not heads times the probability of getting not heads again. So this is coming around from here. I'll just put this in a little box to know that that's how we got our probabilities of not heads and not heads. So here we have 0.5 as our probability of not getting heads, so we're just going to plug in 0.5 for each of these. So to find the probability of getting tails and then tails, we're going to multiply our probability of getting not heads times our probability of getting not heads. 0.5 times 0.5 comes out to 0.25. What all of this means is that our probability of getting tails and then getting tails again is going to be equal to 0.25. And that's because that's our probability of getting not heads and then getting not heads again. And the reason that I'm talking through it this way is that, again, it's just helpful for practicing these rules to think about it in terms of it being not heads as opposed to calling it a different probability. All right, so the next thing we want to do is find the probability of getting 1 heads in our double coin flip. I guess one heads, I'll call them 1 heads. So in order to get 1 heads in our coin flip, we have 2 options. So we can either get a heads and then a tails, or we can get a tails and then a heads. So we have 2 different ways to come up with this outcome. So now we're going to be combining even more of these rules. And for the first one here, we're going to say we've got the probability of getting heads and the probability of getting not heads. So we want to know the probability that we're going to get heads in our first flip and then something that's not heads, tails, in our second flip. So using this probability notation that we have, we're going to write this out as being the probability of getting heads and not heads. This tells us that we need to use the multiplication rule again. Anytime you see an and in the middle of your probability, that means that you're looking at the multiplication rule. So here we want to know the probability of getting heads and then getting the probability of getting not heads. I'm not going to go through this again since we already have up here that our probability of getting not heads is 0.5. So instead, I'm just going to go straight to the multiplication rule, and we'll say that in order to find these probabilities, we're going to take the probability of getting heads and multiply it times the probability of getting not heads. So now we can plug in these values. We know our probability of getting heads is 0.5. We know our probability of getting not heads is 0.5. So we're multiplying 0.5 times 0.5 again. And that comes out to 0.25. So what this tells us is that when you flip a coin twice, the probability that you're going to get heads on your first flip and then tails on your second flip is equal to 0.25. But we're not done yet, because when you flip a coin twice, there's 2 different ways to get 1 heads. And the other way that you can get that is if you flip it and first it comes up tails and then it comes up heads. So in other words, we're looking at the probability of getting not heads in your first flip and heads in your second flip. So again, we have an and here. We want to know the probability of this outcome occurring and then this outcome occurring. So we're going to be looking at that multiplication rule again. So I'll write this out. We're going to multiply our two probabilities together. And the only thing that switched here from the last one is the order that I'm writing them in. So here we had the probability of getting heads and not heads for the first one. For the second one we're doing in this example, we have the probability of getting not heads and then the probability of getting heads. So we can plug in these numbers again. Our probability of getting not heads is 0.5, and our probability of getting heads is also 0.5. And this comes out to 0.25 again. But we're still not done on this one. And the reason now is that we're saying that if we want to get 1 heads out of our 2 coin flips, we need to have this outcome occur or this outcome occur. So out of our 2 coin flips now, we're looking at 1 event with 1 outcome. We want to know the chances that it's going to be either this outcome, heads and then tails, or this outcome, tails and then heads. So when we're looking at a question about 1 outcome or another outcome, we're going to come over to our addition rule. So I'm going to write out one more thing here because this is really the way we can get 1 heads. We want to know the probability that we're going to have heads and then tails, or tails and then heads. So once we find this one, we'll know the probability of getting heads 1 time in our 2 coin flips that we did. So when you're looking at an or, you want to think addition rule. And so I'm going to write this out again and say we have the probability of getting heads first, tails second, or tails first, heads second. And to find that, we're going to add these together. So the probability of... We want to know the probability of getting heads then tails, or the probability of getting tails and heads in our single event. So in 2 flips of the coin. So I'm going to plug in these numbers here. We said that our probability of getting heads and then tails is equal to 0.25. That's what I have right here. Our probability of getting tails and then heads right here is going to be equal to 0.25. So we're just going to plug these in. 0.25 plus 0.25 comes out to 0.5. So we just use all these rules. We have our converse rule, we have our multiplication rule, and we have our addition rule to come up with a probability of 0.5 for getting heads once in 2 coin flips. And so I'm going to put that in there in our probability distribution. So all that gave us this one line in the probability distribution, which tells us that when you flip a coin twice, again, when you flip it, and then flip it again, the chances that you're going to get heads 1 time is equal to 0.5, or a 50% chance. Right, so our final value in our probability distribution is going to be the probability of getting heads twice in those 2 coin flips. So if you think about flipping a coin twice, there is only one way to get heads twice. And so for that to happen, you have to get heads in your first coin flip and heads in your second coin flip. And there's no other way to get 2 heads out of 2 coin flips. So this one, the calculation is going to be a little bit easier than for 1 heads because we only have one way of getting this outcome. So here we need to know the probability of getting heads and heads again. So what's the probability? You're going to flip a coin twice and then get heads and then heads. So to find this, we only have one rule we need to think about here, and that's the multiplication rule, because we're talking about heads and then heads again. So I'm going to write this out with the multiplication rule, the probability of getting heads times the probability of getting heads. And if we plug in these values, probability of heads is 0.5, probability of heads, 0.5. It gives us 0.5 times 0.5, which gives us 0.25. So we can finally fill in our last value here, which is going to be 0.25. And again, what we went through here, partly we're just practicing using these rules to find different probabilities, but also we're filling in a probability distribution that's based on theory. So for this one, for our 2 coin flips, we're saying that based on these rules, based on what we know about the probability of getting heads or tails in a coin, if you flip a coin twice, you have a 25% chance of getting no heads at all, you have a 50% chance of getting heads once, and you have a 25% chance of getting heads both times you flip the coin.